All right, welcome to the last part of this. You've got some exercises to do to practice what we went over with those last examples. So this first one here, exercise 2. My hint for this, if you can do it on your own, that's great. If you're kind of stuck, my advice is to fill in this table. Make sure that you know what 4 to the power negative 2 is, 4 to the power negative 1 is, 4 to the power 0, 4 to the power 1, and 4 to the power 2. Thinking about those should hopefully help you figure out what kind of value of x works here. Like in between which of these kinds of numbers are we talking about? So, and then exercise 3 is like example 2, where you're just going to practice solving by graphing with a calculator or on Desmos.com. And you can check to make sure you got the stuff in the last question using that. And then exercise 4 is going to be like example 1. Some of these can be pretty tricky. So if you're stuck on these, I recommend going back to those examples before you watch my solutions, because you'll get a lot more out of it that if you can figure it out yourself. The more you see me do, the less you're really doing yourself, and you're not going to get as much out of it. So that's my advice. I'm going to whistle for a moment while you pause it to work on these, and I'll show you all the answers in a moment. Okay, we're back. We want to do 4 to the x equals 3. So I'm going to follow my own advice and fill in this table. 4 to the power negative 2 is 1/16. 4 to the power negative 1 is a fourth. Anything to the power 0 is a 1. 4 to the power 1 is 4. And 4 squared is 16. Okay, so 3 is in between 1 and 4. It's a little bit less than 4. So the x that works is going to be in between 0 and 1. So I'm going to say x is in between 0 and 1 is my answer. And if you just want to write it like this in words, that's fine too. All right, so here, well, I think it's easier, like the 5 might be confusing things, and you can easily cancel out the 5 by just dividing both sides by 5. So if you get 4 to the x equals 10, well, let's see, that 10 is somewhere in between 4 and 16. 4 to the power 1 is 4. If the x is 1, it would be too small. 4 to the power 2 would be 16. That x would be too big. So it's that this x is going to be greater than 1 anyways, is what we're looking for. So that's the greater than 1 option there. All right, so with this one, it's a little weird because we have 1/4. I don't actually have 4 to a power. So how is thinking about powers of 4 going to help you here? Well, there's a trick. If we were to write that 1/4 as 4 to the negative 1, and then that to the power x equals 3, you'll see we have 4 to the power negative x equals 3. So negative x is between 0 and 1. So if negative, just using the result from example A, it's just we have 4 to the power negative x this time instead of 4 to the power x. So that gave you that x between 0 and 1. Now we're going to have negative x is between 0 and 1. So if negative x is between 0 and 1, then x must be between negative 1 and 0. This one's a tricky one. Okay. If you got this one wrong, don't beat yourself up. That I think most people probably did. But that's okay. You're learning. Let's look at exercise 3, solving these with a graphing calculator. So we want to do 4 to the x equals 3. And over here we're going to have y equals 3. So yeah, it looks like, yeah, somewhere between 0 and 1 probably. Zoom in there a little bit better. Yeah, it looks like about 0.7-ish. Or sorry, more like 0.8. 0.792. Okay. For the next one, we want to do 5 times 4 to the x equals 20. So I'm going to write the 5 times here. Y equals 20 over here. So you can see this. So wait, 50. Why did I say 20? Excuse me. This is supposed to be y equals 50 because we're doing 5 times 4 to the x on one side, and the other side should be 50. So I want to see what x makes it so these two y coordinates are the same. So zoom out a little bit here, and there's the solution. .661. So yeah, it's greater than 1. And 1/4 to the x equals 3. Let's look at that. Okay, so yeah, we can see the solution is over here. So we have negative 0.792. And you might notice the symmetry between this this result here and this result over here, because really we are talking about whatever x makes this negative x equal to positive 0.792 is what's going to make 4 to the negative x equal to 3. So yeah, A and C are kind of related. All right, so exercise 4, we got to practice doing it without graphing and then check your answers. So for this one, first of all, the 5 is just in the way, and you can get rid of it easily by dividing both sides by 5. It will cancel out. So, because it's just regular old multiplication here. So that gives you 2 to the power x equals 320 divided by 5, I think is 64. Yep. Okay, so 2 to the x equals 64. So 64 is 2 to what power? 2 squared is 4. 2 to the power 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. That's what will work. So that solution is going to be x equals 6. Alright, you have a square root here, which makes things a little annoying. We're still going to try to write everything as 2 to a power equals 2 to some other kind of power. And whatever makes those powers equal must make both sides of the equation equal. So the square root you can write as the exponent 1/2. That way we don't have a square root in it anymore. And then you could, if you have a power to a power, you can multiply them together. So that'll be 2 to the power t over 2. And that's good. All right, and then over here, the 4 you can write as 2 squared. So I'm going to write this as 1 divided by 2 squared. And if you don't want to have that fraction with a 2 in the denominator, you can write it as 2 to the power negative 2. All right, so this is now giving you, we have 2 to a power and 2 to a power. And once you have that, the powers must be the same. You have t over 2 equals negative 2. So I can multiply both sides of this by 2. That gives you t is negative 4. All right, I said I was going to check these answers. Let's actually go back and check them. So with the first one, we're going to do 5 times 2 to the power 6. That gives you 320. With part B, if I want to do the square root of 2 to the power negative 4, that gives you 0.25, and of course 1/4 is also 0.25. Good. Okay, this one is a little bit weird. You might be thinking, oh my gosh, there's this messy fraction with these square roots in it. But wait, there's a 1 on the other side. So if you want, you could still think of it as 2 minus the square root of 5 over 5 minus root 7 and all that mess to the x equals this whole thing to what power? What would that exponent be that makes this whole thing become 1? Well, let's think. What is anything to the power 0? It's 1, right? Yeah, anything to the power 0 is 1. So that means this could just be 0, and so your solution is x equals 0, and it doesn't matter what was in those parentheses. And this is one where I don't need to check it because I know anything to the power 0 is 1. So I guess if you wanted to check it, you could. It doesn't hurt to just use a calculator to verify what you know, but I'll let you do that yourself. Anyways, thanks for getting through this video. I hope this one was a little bit quicker than 6.2 and 6.3. Those ones were those were some of the trickiest sections in the class. So we're back to some sort of more straightforward stuff, I hope, for now. Chapter 7 is going to get a little bit weird again, though. So anyways, I'll see you in the next video. Good luck with the quiz. Remember to take your time on it. You might need to come back and watch some of the parts of this video again that you maybe didn't understand. Anyways, good luck.